Hi, my name is Miguel and I will try to explain how does style transfer work in a very simple way, including the code as well. Before watching this video, I would like to encourage you to read the original paper, the one you can see here, because it's very easy to read and simple to understand. First of all, we can see some examples from the original paper to illustrate the main idea. The conclusion of the paper is that in a convolutional neural network, we can separate the content and the style of images. This paper is then like a proof of concept, which takes the content of an image, like the houses we can see in the top left figure, and the style of famous paintings to combine them. This can happen because they are separable. That's basically the main idea. After this paper was released, which is already around 2 years old, there were a lot of improvements and new ideas around it. That's why I personally think this paper is very important, because there will probably be more and more research based on the style transfer. So I wanted to explain it. For instance, you could make videos by converting each single photogram, or maybe just doing something more clever, or you could combine various styles instead of just one, and you can definitely improve the results given in the first paper. There was a very recent paper that came out some weeks ago in which they explain how to harmonize foreign objects in paintings, and I think it's very interesting. Since I'm assuming you read the paper and I want this video to include the code, I will describe how style transfer works in a simple way through the code I wrote. I found a lot of implementations of style transfer in Python, but to be honest, I couldn't find a simple one, so I wanted to make my own, keeping it as simple as possible. In other people's code, you can see that they try newer algorithms, they add parameters to make it easier and more flexible, etc. But for understanding the main idea, which is very simple, I think it's a bit challenging to read, especially if the code is not well commented or if it doesn't have comments at all. The code I provide is around 150 lines with comments, and it's fully working, so you can just run it as it is. I used object-oriented programming style, so we will first create an object in which we will add the configuration that you can check in the code, and I also will pass the content and the style images. After that, we will train it, and we will specify the learning rate and epochs. And by the way, I wrote a -1 because I don't want to give any learning rate in the original optimizer algorithm. You can see this in the code. Finally, we will save the result. And you can see it's very simple. By the way, I'm not going to show all the code in this presentation, but you can access to it in the link I will write below. When we create the object style transfer, we will call the other methods to read the images, create the model, and create the loss function. There is one important thing in the code that I would like to mention, and is that since I will load some weights, we need to load a session as well. If we write a typical function global variables initializer in the beginning, it will wipe out the loaded weights. So just don't do it and look at how I do it in the code. We will load images using an external library and NumPy. Then we will create the model, and for this we will use the object VGG16 in Tensorflow keras, as we can see in the last line of the function. The input tensor will be a combination of 3 different images: the content image, the style image, and the combination image, which at first it will just be a random noise. After these images are combined, the shape of the input will be 3 by 512, 512, 3. The 512 comes from the configuration specified when creating the style transfer object, and the last 3 comes because we are dealing with RGB images. Now, the advantage of using the already defined VGG16 is that we don't have to worry about its internal code. We know it looks like this, and sorry if you cannot see well the image due to the resolution, but you can find this image anywhere when you search about VGG16. This is actually VGG19 because it includes the last 3 fully connected layers. Anyway, we will choose a convolutional layer from where we will extract the content, and then we will choose 5 convolutional layers for extracting the style. Now we will create the loss function, and this is the important part that we really need to understand about style transfer. After the input is presented to the network and a first convolution is performed, the output will have the same dimensions as the input because we preserve the dimensions. Therefore, the output of the first convolution We'll also have a shape of 3 by 512, 512, 3. Regarding to the content loss, we will take the first and the last slice, corresponding to the content and the combination images respectively. The loss will be then calculated as described in the original paper. So just taking into account the slices and some square and then we sum it. It's very simple. Then the style loss is a bit more complicated to calculate. The first difference with the content loss is that this time we need to calculate it over several layers and not just one. That's why we have the for loop in the beginning. The second difference is that this time we won't use the results of the convolutional layers directly, but we use their gram matrices. For instance, the output of the convolutional layer is 3 by 512, 512, 64. 64 is the number of filters. At first we separate the style from the combination image. So we will get 2 slices of the same dimension. We line up all the features in the rows and then we squeeze the other dimensions. So these are the shapes we get. Then we multiply each of the matrices by itself transposed, and as a result we have 2 gram matrices that we will use to calculate the style loss according to the formula in the paper. The reason why gram matrices are used is because they capture the feature correlations of the layers, and it's a way of representing the texture without taking into account pixel location. So this is basically the opposite of content, right? In content we really want to preserve the location. If there is a house in the top left, we want to preserve it. But when it comes to style, we're not interested in locations. We just want to have a general texture, and this is why we use gram matrices. Finally, as you may have noticed, all losses are weighted, so we can give more importance to the style and less importance to the content, or vice versa. This is really up to you. You really have to play with the weights to get good results. Now we move to the training part, and here there is not much to say. It's just the algorithm itself. We simply iterate for a number of times while we minimize the loss. I'm using the original algorithm by default, but I also commented the implementation of gradient descent to compare results, and when you use gradient descent, then you have to give the learning rate that I wrote before. It was -1. In addition, remember that this is not a normal CNN, where during the training and during the loss minimization we are updating the weights. We want to keep the weights constant and update just the combination image. For this reason, we have to specify which variable we want to update, and doing it this way, it will just update this one and not the other ones. Finally, saving the image has nothing really interesting to say. I'm just using SciPy for that. And that's all. Thanks for watching the video, and I hope you could understand style transfer. Check the full code in the link below, and as I've said, I try to make it as simple as possible, and you can just run it as it is after you download it and you have some images to try it with.